Section 2.2, trig ratios of any angle. Okay, a couple things we have to recall. Recall first of all that an angle theta, you measure an angle in a counterclockwise direction from the initial arm to the terminal arm. The quadrants are labeled with Roman numerals, also in a counterclockwise direction. So next time in your classroom, look in our classroom, look to the right and there's a poster with quadrants, and the quadrants are labeled green, 1, 2, 3, 4, counterclockwise. You'll notice it says in quadrant 2 that it's negative x, positive y. Okay, and I'll remind me to go over that in class. Okay, oh, I need to plug in. Just like school, you guys get to see when I mess up. Okay, how's that, computer? Better? Okay, if the terminal arm lies on an axis, the angle is called a quadrantal angle. Not that important, okay, but 0, 90, so 0, 90, 180, 270, 360. If point xy lies on a terminal arm in standard position, the primary trig ratios are sine is y over r, cos is x over r, and tan is y over x. And we remember this, just like SOHCAHTOA, we go sine is y over r, is y over r, cos is x over r, and tan is y over r. So we say Sir Coxer ticks, okay? And kids usually like saying that, Sir Coxer ticks. That's how we remember this. But again, you guys can bring a sheet in, so you don't have to remember it, but maybe you would like to say that out loud once, okay? So, for instance, if this point is here, x is how far x it is, y is how wide it is, and r is new. R is the distance from 0, and it is represented by r. So using the Pythagorean theorem, because this is a 90-degree, we go a squared plus b squared equals c squared. To get c by itself, we square root. So r is equal to the square root of x squared plus y squared. R is a distance, it's always positive, okay? So they say sine is positive here and here. Why? Well, y in this coordinate is positive, so we have positive, and we said r is always positive, so positive over positive, okay? In this quadrant, we have x is negative, and we have y being positive. So again, sine's going to be positive. And that's where all of these rules came from, and you'll start experiencing that, okay? The other way that people remember it is cast, or all students take calculus, cast. What that means, in the first quadrant, everything's positive. In the second one, only sine, only tan, and only cos in the fourth. Okay, so that might be something that you help remember, cast, or all students take calculus. There's lots of other inappropriate things that students remember this by. You remember how you want, but maybe just be careful how you choose to talk about it, okay? And here they show that again. Let's do a question. So the point 12, negative 9 lies on the terminal arm of an angle theta in standard position. Determine the exact trig ratio for sine, cos, and tan. Okay, so we need to plot this point. So x is 12, y is negative 9, that point is right here. Okay, so remember in standard position, you start, your initial arm is here. This is the angle theta. We learned that the reference angle must be here. Remember, the reference angle is from the terminal arm, where it ends, to your closest x. Okay, so determine the exact trig ratios. Well, from this point, 12, negative 9, we know that x is 12 and y is negative 9. So we can calculate r, because r is equal to x squared, the square root of x squared plus y squared. Well, x squared is 12, so we have 12 squared plus negative 9 squared. Brackets are going to be important here. Okay, so this is equal to the square root of 144 plus 81. Okay, that's equal to the square root. Here we have 5, 12, 225. Grabbing your calculator. Square root of 225 is 15. Okay, so r is 15. Okay, now we can do the exact values as when we sub into Sir Coxer ticks. Well, sine is y over r. We said y was negative 9. R we said was 15. Cox, x was 12, right? over 15. Okay, and y over x, we have negative 9 over 12. Okay, now let's just double check something here. We said that there was the cast rule. Our angle theta was obviously in quadrant 4. So the only thing that should be positive is cos, and that's correct. Everything else is negative. So the word exact trig ratio means leave your answer as a fraction in lowest terms. Oh, are all of these in lowest terms? No, we better fix that up. Okay, negative 9 over negative 15. We could probably do negative 3 over 5. 12 fifteenths is 4 fifths. Oh, that shouldn't be equals. We're just... And this should be negative 3/4. Whew, good thing we read that note. Okay, now determine the exact values of sine, cos, and tan for theta is 120. So first it says sketch it in its standard position, draw the reference angle. So if this is 120, my reference angle, well, this whole thing is 180. So what's left is 60. Okay? Now 60 was something special. 60 was something we learned about up here. Okay, oops, this is what I need to do, 60. We know sine of 60, cos of 60, and tan of 60. These are exact values. These are exact values that you're going to write on a formula sheet. These are things you need to know. Okay, let's go back to where we were. Where were we? Nope. Oops. Here's where we were. Okay, so sine of 60 was... Oh, Ms. Cancelon has a bad memory. I think cos was 1/2. Sine was root 3 over 2, and tan was just root 3. So it's best if you have these memorized, but Ms. Cancelon does not anymore. Root 3 over 2, and this was just root 3. Okay? In quadrant 2, x is negative and y is positive. Determine the sign of each ratio. Okay, so sine over here, we're going to have y over r, a positive over positive. So sine is going to stay positive. We're going to have positive root 3 over 4, or 3 over 2. Okay, cos. In this case, we have x over r. Our x is negative. So our cos is going to be negative. So we're going to take our reference angle, but we're going to make it negative. So this is important. You always have to change because of where you are. Okay, tangent is y over x. Okay, so root 3 over 1. We knew that already. And, oh, that's not what it's asking us. It's asking us positive and negative. Sorry. So y in this case is positive. Tangent, the x is negative. We're going to get a negative value, so it's negative root 3. Therefore, sine is positive, cos and tan are negative in quadrant 2. So we could have done this work. The other thing we could have done is we could have gone back here and we should have looked in quadrant 2 and said, look, only sine is going to be positive. We could have taken our answers and said only sine stays positive, everything else is negative. Okay? So what that means is the sine of 120 is equal to positive sine of 60. Right? That stayed the same. These two switched. Okay, I think I'm going to leave the rest of the questions. Yeah, let's do example number 3 and example number 4 together in class.